So today we will try to understand angle addition trig identities and why sine a plus b equals to this equation and why cos a plus b equals to this equation. And the derivation itself is quite complex and it's not really the focus of what you need to know, but I hope you can understand the intuition behind why this happens. So suppose you know two angles. Let's say A equals to 30 degrees and B equals to 45 degrees. How do you find sine of 75 degrees? As we know from the unit circle, we can find what sine of 30 degrees is and sine of 45 degrees because these are common angles which we are kind of taught to memorize in the unit circle. I can go over that later, but notice how sine of 75, you can rewrite 75 degrees as 30 degrees plus 45 degrees. We're breaking it up into simpler angles that we already know. Now the question is, can we compute the sine of the sum of two angles using the sine and cosine of the individual angles? The answer is yes. That's exactly what the angle addition formula does. So many students, I've noticed, think that sine a plus b equals to sine a plus sine b. And unfortunately, this is not right. So we can just use an example. For example, if you plug in sine 75 degrees into your calculator, equals to sine 30 degrees plus sine 45 degrees, we'll see that these do not equal. You can prove it to yourself. You can type this into your calculator and you can see for yourself it doesn't behave like ordinary addition. And you have to start thinking about rotating vectors and what sine and cosine actually are. I'm going to draw another unit circle real quick. Now suppose there's a point in the unit circle A, and the coordinates are cos A, sine A. And if you remember from trigonometry, cos equals to opposite or adjacent over hypotenuse. So to find this point, we would use cos, let's say this angle is 30 degrees, for example. You would do cos 30 here, and you would, to find the vertical component, we would use sine of 30. And this is what this point A is. This hypotenuse is just the makeup of cos 30 degrees and sine 30 degrees. Again, the horizontal component is found by cos of 30 degrees, and the vertical component is found by sine of 30 degrees. Now let's suppose we rotate this angle another 45 degrees. Unfortunately, this is not drawn to scale, but I'll use the color orange. Let's say this is another 45 degrees. So the total here would be 75 degrees at point B. So what would be the new coordinates for angle B? It's drawn really roughly, but the new coordinates would be cos of 75 degrees for the horizontal component, and for the vertical, it would be sine of 75. Sorry if that's really messy, but just know that sine correlates to the vertical component, and cos of 75 correlates to the horizontal component, and that's how we figure out B. Apologies for the messiness. Now the big picture is looking at these 2 point discrepancies. We see that the vertical component changes a little bit, and we also see that the horizontal component changes a little bit. And we also notice that it is on a 2D space. If we were doing regular addition, we'd go from point A, let's say we go from, like, let's say like we have like a number line here, right? 0, 1, 2, -1, -2. Let's say at point B we're at -2, or let's say to get to point B let's say we're starting at -2. To go to point B, let's say we go from here to here to point B, so we +1, and then from B to A we add another 2. Notice how it's completely linear and it's one-dimensional. But notice here that it's two-dimensional. The point goes a little bit up vertically and also goes a little bit to the left horizontally. So the horizontal and vertical components are changing. And that's why we cannot just do sine A plus B, or sine A plus B does not equal to sine A plus sine B. And instead we're using this equation right here to find sine A plus B. And we're using this equation here to find cos A plus B. And the actual derivation of the formulas is pretty complex and you're not really expected to know, but I think this is a really good starting point for you to understand why sine A plus B does not equals to sine A plus sine B. Thank you.